Hey everybody, welcome back and welcome back to Chapter 4. We're going to start Chapter 4, and Chapter 4 is starting to look at algebra and algebraic expressions. So we're going to start looking at this area over here. When we start to look at terms, need to start looking at terms a bit differently. Notice that we have a term here of 5x and another term here of -3. Now we can't add those together or do anything with them because they're different. But we're going to start filling in this note. In an algebraic expression, I'm running out of room here. Okay, such as this big thing over here, both 5x and 3 are called terms. So those are both called terms. 5x is a variable term, and it's called a variable term because of the x. The x, we're not sure what value it is. The value of it can actually change. So perhaps one time the x is going to be 1, another time the x is going to be 2, and then we see how it can actually change. The term 3 is actually called a constant. The 3 is not going to change. So the 3 is a constant. So we have a variable term and we have a constant term. In the term 5x, which we have here, the 5 is called the coefficient. So the number in front of the letter is a coefficient, and the letter, and in this case, x, is called a variable. And it's called a variable, again, because I said earlier, it can change. So we have a variable term, because it has a variable in it, and we have a constant term. And in this one, the 5 is a coefficient, or whatever number is in front of our variable is called the coefficient. Like terms. Well, these terms have the same variable and exponent. We looked at exponents in Chapter 3. Remember, an exponent would be if we had x squared, 2 here is the exponent. Okay, they can be combined by adding or subtracting. So like terms, These terms have the same variable. So if it is a variable term, it has to have the same variable. It can't have an x and a y. We can't add an x and a y, but we can add x's together. But they also have the same exponent. We'll do some examples here. So 2y and 8y are like terms. And if we were to add them together, we have our 2y plus our 8y. If I had 2y's plus 8y's, we'd get 10y's. Those are like terms, so we can add them. My next example, if I had 3x squared and 5x squared, these are also like terms. So we would have 3x squared, sorry, I wanted this to be a minus 5x, minus 5x squared. Make sure I put my exponent in there. They are like terms also. They have the same exponent and they have the same variable. And we can add these together, and actually we're subtracting them. So we're going to say 3 minus 5, so 3x squared minus 5x squared is going to give us negative 2x squared. Well, now let's look at what unlike terms are. Unlike terms have different variables or different exponents. And they cannot be combined by addition or subtraction. A couple of examples here. 3x and 7y are unlike terms. I can't add an x and a y. My grade 9 math teacher always said you can't add apples and oranges. Sure, you can have a fruit salad, but you can't say, well, I have an apple orange. No, you'd have one apple and you'd have one orange. In this example here, we also have a 2x squared and 6x are unlike terms. They have the same variable, but they don't have the same exponent. So here we're looking at like terms and unlike terms. Our next part says algebraic expressions are also called polynomials. Polynomials. And then it says polynomials are expressions in which terms are added and subtracted. And I'll scroll down here. Remember, throughout these videos, you can rewind or stop or pause whenever you need to. We have a monomial. And if we think of a monorail, it would have one rail. An example of this could be 3x squared. There's just one term there. We have a binomial. I look at that and I see bicycle, or I see bipeds, which are species or animals that have two legs. And they have two terms, 4y cubed plus 7y. I can't add them because they're different. The exponents are different. So it is a binomial with two terms. In a trinomial, we look at tricycle or tripod, and we can see an example here, 6x squared minus y squared minus 2. That is a trinomial. I can't combine them. I can't combine them because they are not like terms. Polynomials can be added and subtracted, and this is done by adding and subtracting the like terms. Combining the like terms, that's called simplifying. Simplifying. I'm spelling that word wrong. Let me erase that and do that again. Simplifying. Okay, and that is called simplifying. Let's do a few examples, and hopefully all the stuff will get making some sense for us. Well, on the first couple, and I'll do the first couple of examples with us, and then I'll have you do them. The first example says circle the coefficient, underline the variable, and box the constant. So my coefficient, if we look back at our other sheet, the coefficient is the number in front of the variable. In this case, it's 3. I want to underline, so circle the coefficient, so it's going to be circling the 3. I want to underline x squared because that's my variable, and I want to put a box around the coefficient. Remember, the coefficient is a number all by itself. It doesn't have a variable. So we circled the coefficient, we underlined the variable, and we put a box around the constant. Let's do one more example together, and then I'll have you do these other two on your own. We're going to circle the coefficient. The coefficient in this term is 5. We're going to underline the variable, and the variable is y. We're going to put a box around the constant. The constant is 4. So in a moment, you can do this question and this question on your own. Now I'm going to look at this next part here. I'm going to look down here and figure out, okay, is it a monomial, a binomial, or a trinomial? Remember, a monomial has only one term, a binomial has 2 terms, and a trinomial has 3 terms. Well, the first one, we can see that these are different terms because of the variable. They are unlike terms. So this one would be a binomial. Let me put that in a different color so we can see it easier. This would be a binomial. Well, this one, how many terms does it have? It just has the one term. It would be a monomial. I'd like you to do these questions on your own. If you want to pause it, you can pause it and finish that one and then come back to the simplifying part. I'm going to go ahead and go with some of the simplifying questions. I'm going to scroll down just a little bit. Well, here I want to combine like terms. And a good habit to get into is to first of all recognize what are my like terms. What terms are the same? Well, these are the same because they are like terms because the variable and the exponent are the same. Now, actually, we don't see an exponent When we don't see an exponent, we can assume, and we know that the exponent is actually 1, but we know that these are the same. So we have 3x plus 4x. Well, I can add the coefficients, and I can get 7x. I'm going to go over to number 2, and I'm going to look at it, and I have 4x squared plus 6 plus 5x squared. I'm going to underline my like terms, and I'm going to try to simplify this question. I have 4x squared, and I have a 5x squared, so I really have 9x squareds, and I still have that 6 left over. And really what I should have done is either underline this in a different color or even a different kind of symbol, and I can visually see what my different terms are. Well, let's go to number 3. I'll do number 3, and I'll also do number, I think I'll do number 5 with us, and then you can do the rest on your own. In number 3, we have 6x cubed. We don't have any other x cubes here, but we do have a 4x and a 3x. So this gives a different little notation underneath of it. So I'm going to leave my 6x cubed up here, and I want to add those other two. And I have 4x plus 3x, which will give me 7x. A good habit as I'm writing my answers down is the variable with the highest exponent always goes to the left. So the variable with the highest exponent always goes to the left. Let's see, what other one did I say I was due? I think I said I would do number 5 with us. So we want to underline our like terms. Well, the 3x is the same kind of a term. So it's a like term with all of them. So we're going to say, okay, I'm going to do this in an extra step just to help me out. So 7x minus 5x equals 2x. And now I have simplified that question. Number 7 is a little bit tricky. It's got a bunch of terms in there for you to look at. And number 8 is a little bit tricky too, because it even throw in a few other letters there. But you would still underline your like terms, add them, and see how you go. So you've got a few more questions to try there. Also, when you're done that, don't forget we also have some practice questions, which can be found on page 257, exercise 1, 2, and 3, exercise 4, just A through I, question 5, A through I, and question 6. If you're running stuck, maybe you want to talk with a neighbor or figure out with a neighbor. Also, good idea to every once in a while just go back to that very front page that we looked at. Make sure you know some of these terms, and especially become familiar with this piece over here so that we really know these terms and are able to understand what the different pieces are. Talk to you in class.